In today's lesson, we're going to learn about equations of proportional relationships. In our previous lessons, we saw that a relationship is proportional if in a table of values there was a constant unit rate, and we know a relationship is proportional on a graph if we saw a straight line that passes through the origin. Okay? When two variables are proportionally related, we can write equations that find the value of one of the variables if we know the value of the other variable. Okay, so that's what our goal is here today. If we have a proportional relationship, what will the equation of that relationship look like? In our first example, we're looking at frozen yogurt. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they found. Determine if the cost is proportional to the weight. So the first thing that we need to determine is, does everybody pay the same cost per ounce? Okay, so looking at my rates here, I can see the weight in ounces and I can see the cost associated with those. All right, when I set up my rates, I'm going to do dollars per ounce. Okay, dollars per ounce is what we want to know. So with the first set of data, I can see that it costs $5 for 12 and a half ounces. I'm going to simplify that down to a unit rate by dividing each number by 12 and a half. And when I do that, I'm going to get 4/10 over 1. For my next rate, I see it's costing $4 for 10 ounces. Divide each number by 10 to get the unit rate. And again, we're going to get 4/10 over 1. For the third example, it was $2 for 5 ounces of yogurt. Divide both numbers by 5, and we're going to get 4/10 over 1. And finally, we have $3.20 for 8 ounces of yogurt. Divide each number by 8, and that once again gets us to 4/10 to 1. So we can say everybody pays. Okay, and then if we see what this is, 4/10 of a dollar, well, that's 40 cents. 40 cents per ounce. Everybody pays 40 cents per ounce. Okay, so the cost is proportional to the weight. And the unit rate we just set up here was 40 cents per ounce. Okay, so just like with the examples with the graphs, in this relationship, there is an independent variable and there is a dependent variable. Think about this example. Does the weight of the dish depend upon how much it costs, or does the cost of the dish depend upon its weight? All right, well, we said back up here that the price is based upon the total weight. So the price depends upon the weight. So coming down here where we're identifying our independent and dependent variables, okay, the independent variable is going to be the weight in ounces. You can get as much yogurt and toppings as you want. That's independent. The cost will change the more yogurt and toppings that you get. So the dependent variable is going to be our cost in dollars. Okay? Using what you have found above, fill in the blank. Y over X. Well, if we go back to our table, our Y value, that was the cost in dollars. All right, so I'm going to put a Y right there in cost. And my X value was the total weight. But notice when we set up our rates here, we did the dollars first, which was our Y value, Y over X, which is our number of ounces. Every time we simplified these rates down, we ended up with the rate of 4/10 over 1. So in this case, we can say that Y over X is equal to 4/10. Okay, Y over X was equal to 4/10. That's the same as 4/10 over 1. What we want to do now is come up with an equation that we could use to represent this example. So what we have to do is isolate the variable y in the equation that we have just completed, in this equation right here. So it says y over x equals 4/10. We have to get y all by itself. We have to isolate y. Well, right now, y is being divided by x. Therefore, to isolate y, we're going to have to multiply both sides by x. Multiply both sides times x. On the left-hand side, the x in the numerator and the x in the denominator simplify to ones. So this now just says y on the left-hand side, and it equals 4/10 times x, which is just 4/10 x. Okay? This is the equation of the proportional relationship. All right, we saw earlier that we got the constant unit rate of 4/10 over 1, or 40 cents per ounce. This equation now is going to be used to represent this relationship. This equation can be used to calculate the cost of any number of ounces of frozen yogurt. Use this equation to answer the question below. So if we look at the question below, we're told that Isabel's brother takes an extra long time to create his dish. When he puts it on the scale, it weighs 15 ounces. If everyone pays the same rate in the store, how much will his dish cost? Okay, well, I now have this equation that I can use in order to figure that out. So I'm going to start by writing my equation. Y equals 4/10 times x. And we know that Isabel's brother's dish weighs 15 ounces. 15 ounces. Well, if we remind ourselves back up here, your weight in ounces was the independent variable, which is x. So we're going to substitute in 15 for x in this equation. Y equals 4/10 times 15. Remember that we set up here the dependent variable y is the cost. So what we're going to have to do is figure out the cost y by multiplying 4/10 by 15. Y equals, when we do 4/10 times 15, we should get a value of 6. This means that this dish of frozen yogurt, costs $6. Okay, Isabel's brother's dish of frozen yogurt will cost $6. So again, our goal is to create our equation. Our equation in this example said y equals 4/10 times x. X is your weight, y is your cost in dollars. So in our last example, we saw that the unit price was 40 cents per ounce. Okay, the unit price equals 40 cents per ounce. Okay, if that was our unit price, that means that K, our constant of proportionality, was equal to the 4/10 or the 4/10 over 1 that we got when we simplified each rate down. That was our value of K. Well, notice when we wrote our equation said y equals 4/10 times x. That's no coincidence, okay? In the table, if x and y are proportionally related with a constant of proportionality of k, then the equation can be written in the following form. Put a star right next to this. This is what the equation of a proportional relationship will always look like. Y equals k times x, where k is the value of the constant of proportionality. So in our equation up here, y equals 4/10 times x, we just took that value of k and substituted it in, okay? Any equation written in this form represents a proportional relationship. When two variables are proportional, one variable is a constant multiplier of the other variable. The multiplier is the constant of proportionality, again, which is called k. So if you have an equation that looks like y equals k times x, you know that you are working with a proportional relationship. In example 2, we have a cooking cheat sheet. It says in the back of a recipe book, a diagram provides an easy conversion to use while cooking. Okay, so in the top row here, these are the number of cups, and it converts it down here into the number of ounces. And what we want to know is the number of ounces proportional to the number of cups? How do you know? All right. Well, we have to think about which of these is the independent variable and which is the dependent variable. Your number of ounces depends upon how many cups you're working with. So the number of cups is the independent variable, which is x. That means that the number of ounces is the dependent variable, which is y. When we set up our rates, remember that we always set it up as y over x, the dependent variable over the independent variable. In this case, we are going to do ounces over cups. Okay, so if we look at our first set of data from the table, now 0 cups is 0 ounces. That makes sense. There's really no data here to compare. So what we're going to do is look at the second set right here. There are 4 ounces in a half of a cup. 4 ounces in a half of a cup. All right. This is a complex fraction. In order to get this to a unit rate where we have a denominator of 1, we would have to multiply a half by 2. So I'll do 4 times 2, and that'll get us to a unit rate of 8 over 1. The next rate from the table, there are 8 ounces in 1 cup, 8 ounces in 1 cup, and that already is a unit rate. So we can move on to the next set where it says that there are 12 ounces in 1.5 cups. 12 ounces in 1.5 cups. Make this a unit rate. We could divide both of these numbers by 1.5. And when we do that, we get 8 over 1. And finally, there are 16 ounces in 2 cups. Divide both numbers by 2, and we get 8 over 1. So we can see everything simplifies down to 8 over 1. So we can say the number of ounces is proportional. It is proportional to the number of cups. Okay, and we know that because there is a constant unit rate. There is a constant unit rate. All right, so now again, we need to state our independent variable and our dependent variable. Remember we said before that the number of ounces depends upon the number of cups. So that means the number of ounces is y, which is the dependent variable. Dependent variable is the number of ounces. That means your independent variable x is the number of cups. Number of cups. Okay, now that we know which one is independent and which one is dependent, what we need to do is represent the cups with x and the ounces with y. Again, the number of cups independent, that's x. Ounces is dependent, that's y. For any number of cups x, how do we find the number of ounces y? Write an equation to represent the number of ounces in an unknown number of cups. Okay, well, we just set up here that the number of ounces is proportional to the number of cups. And if we want to make an equation, we set up above here that the equation has to look like y equals k times x. So if we come back down here where we're going to write our equation, if it's y equals k times x, all we have to do is substitute in the value of k for this example. So if we look back up here at this example, we can see that k equals 8 over 1, or just plain 8. So let's substitute that value into this equation. The equation is going to say y equals 8x. This is the equation that will convert any number of ounces, any number of cups rather, into the number of ounces. All right, so with the follow-up question, it says, how many ounces are there in 4 cups, in 5 cups, and in 8 cups? Use your equation to solve each problem. So I'm going to divide my work up into 3 areas here. Okay, and I'm going to write my equation first in each part. Y equals 8x, y equals 8x, y equals 8x. This equation, again, will convert any number of cups into ounces. So we have to convert 4 cups, 5 cups, and 8 cups into ounces. Remember that your number of cups is independent, so you substitute that in for x. So let's start with 4 cups. We're going to substitute 4 in for x right here. Y equals 8 times 4. That means that y equals 32. And remember that y represents your number of ounces, so we can label that as 32 ounces. There are 32 ounces in 4 cups. Okay? In 5 cups, again, that's your x value substituted in. Y equals 8 times 5. 8 times 5 is 40, so y equals 40 ounces. And finally, in 8 cups, 8 cups is your x value. Y equals 8 times 8. 8 times 8 is 64. And again, the units are ounces. There are 64 ounces in 8 cups. In example number 3, we have a jumping rope activity. During Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. In this example, we can see the calories burned while jumping rope. So the top row shows the time in minutes, and the bottom row shows how many calories would be burned in that amount of time. In example A, we want to know, is the number of calories burned proportional to the time? So we're going to take the data and we're going to set up our rates. We want calories per minute. Calories per minute. All right, so looking at our table, again, 0 minutes, 0 calories are burned. That makes sense. We haven't started exercising yet. So let's move to where we've got data. In 1 minute, 11 calories were burned. 11 calories were burned in 1 minute. That's already a unit rate. Our denominator is 1. So we can move on to the next set of data. 22 calories were burned in 2 minutes. 22 calories burned in 2 minutes. Divide each number by 2, and we get 11 over 1. Next set says that there were 33 calories burned in 3 minutes. 33 calories in 3 minutes. Divide both numbers by 3 to get to our unit rate, and that would be 11 over 1. And finally, there were 44 calories burned in 4 minutes. Divide each number by 4, and we end up with a unit rate of 11 over 1. So we can say that the number of calories burned is proportional to the time because there is a constant unit rate. Okay, when we simplified everything down, each time we got 11 over 1, so we know that there is a constant unit rate. And that unit rate, if we pay attention to our labels, is 11 calories per minute. So we can even say that it's 11 calories per minute. 11 calories per minute. Now, in the next section, they want to know which quantity is the independent variable x and which one is the dependent variable y. Well, if we think about this example, okay, the number of calories burned depends upon how long you've been exercising. So in this example, the time in minutes is your x value. That's your independent variable. The independent variable is the number of minutes. Okay, you can exercise for as long as you want. The more you exercise, the more calories you are going to burn. So your y value is going to be the number of calories. The number of calories, all right, the number of calories burned is dependent upon how long you have been exercising. Okay, so if we think about how we set up these rates, calories was y, time was x. This was, again, y over x. And in order to calculate k, our constant of proportionality, k equals y over x. And each time we did this example, we ended up with a simplified ratio of 11 over 1, okay, which is the same as 11. So what they want us to do is write an equation that represents the number of calories burned in an unknown number of minutes. So remember, the equation has to look like y equals k times x, Since we know that k equals 11, just substitute that in, meaning that our equation down here is y equals 11x. This equation can be used to determine how many calories are burned in any number of minutes. So if we have a follow-up question now, if Jose jumped rope for 6.5 minutes, how many calories would he expect to burn? Use the equation written above. So there's our equation. Let's write it. Y equals 11x. Jose is jumping rope for 6.5 minutes. Your number of minutes right here, that's your independent variable x. So substitute in 6.5 for x. Y equals 11 times 6.5. And when you do the multiplication, 11 times 6.5, you get 71 and 5/10. So we would say that Jose would burn 71.5 calories in 6.5 minutes. Okay, so since we knew up above that this was a proportional relationship, we can create the equation by substituting the value of k into y equals k times x. In this case, k was 11, so y equals 11 times x. At the bottom of our page, we have some review, okay? We've spent the last few lessons learning about proportional relationships, and we have used tables, we've used graphs, and now we've looked at equations to represent proportional relationships. A table shows that a relationship is proportional if there is a constant unit rate. Okay, in the examples that we did today, we took the data from the table, we set up our rates and simplified everything down to the same unit rate. That means that they were proportional relationships. A table shows a proportional relationship if there is a constant unit rate. Last example, or last lesson, we learned about graphs. A graph shows a proportional relationship if, number one, there is a straight line. We need to have a straight line on our graph. And two, it passes through the origin. All right, the line passes through the origin. If you have a straight line that passes through the origin, then you know that the relationship is proportional. If the line isn't straight, or if it doesn't pass through the origin, then you know that it will be a non-proportional relationship. And then today's takeaway, an equation represents a proportional relationship if it is in the form of y equals k times x. If you have an equation that looks like that, then you know that you're working with a proportional relationship. If you know the relationship is proportional and you need to make the equation, all you have to do is take the value of k and substitute it into this equation.